Hello, sorry about that, but we are back to talk about prisms. This is the final part of the refraction and reflection of light tutorial. We talked about prisms and how they can diffuse light and spread apart white light. You know that light bends because of a change in its speed when it travels from one medium into another. Light travels at a constant speed of about 3 times 10 to the 8 meters per second in a vacuum. However, as light enters a different medium, its speed changes. If light travels from a faster medium to a slower medium, the speed decreases, and vice versa. When white light passes through a prism, it experiences a change in speed and splits into its constituent colors. Each color will travel with its own characteristic speed depending on its frequency. In a slower medium, high frequency light such as violet will slow down more than low frequency light such as red. Because violet goes slower than red in a slow medium, it will bend more than red when it enters a slower medium. It also speeds up more and bends more when going into a faster medium. You can see both effects in this prism. The phenomenon of white light splitting into its constituent colors on refraction is called dispersion. In this video, you will see how white light is split into its spectrum of colors when it enters a prism. You will also see how a rainbow is created. As you watch, see if you can predict what will happen to the light rays when they are refracted. Once you have watched the video, click next to answer a question based on what you observe in the video. And right, well, that's all you really need to know. But if you want to watch this, go back and watch it because I can't show the copywritten material myself. As white light enters a prism, it splits into a spectrum. What happens to the light when it emerges from the prism? The spectrum bends even more. A rainbow is created by the refraction of light through water droplets in the air. When sunlight hits a water droplet, part of the light is reflected from the surface and part of it is refracted into the water droplet. The light that enters the droplet bends and the white light disassociates into its individual frequencies. When the refracted light reaches the other side of the droplet, it is again partly reflected back into the water droplet and partly refracted into the air. Reflected colors once again hit the side of the droplet and undergo partial reflection within the droplet and partial refraction into the air. In this way, light from the sun that enters the droplet comes back out generally toward the sun again, but now that light is broken up into its individual frequencies. So if you face a rainbow in the sky, your back will always be towards the sun. Each water droplet refracts all the colors, but from your distant location, you see only one color coming from any one droplet. You'll see red on the outer edge of a rainbow and violet on the inner edge. So, in a rainbow, a ray of white light enters into a water droplet. What happens to that ray of white light when it emerges from the water drop? It splits into spectral colors with different frequencies. And now that's it. We're back on the summary again. So in this lesson, you explore the phenomena of reflection and refraction of light. When light is incident on a surface, it is partially reflected from the surface. And if the new medium is transparent, it may be partially refracted through the surface into the new medium. The law of reflection states that the angle of reflection is the same as the angle of incidence. A smooth, shiny, and flat surface, such as a flat mirror or still water, causes specular reflection, in which parallel light rays are reflected from the surface in parallel. A rough surface, on the other hand, causes diffused reflection, where the light rays are scattered in all directions. Devices such as solar ovens and periscopes work on the principle of specular light reflection. Whenever a light ray enters a new medium, it experiences a change in speed because the properties of the medium change. This change in speed causes the light ray to bend in the new medium. When light travels from a slower medium to a faster medium, it bends away from the normal. It bends towards the normal if it travels from a faster medium to a slower medium. You've seen that a mirage on a highway on a hot day, the apparent bending of a stick in water, and a rainbow are all caused by refraction of light. You've also examined how white light that passes through a prism is split into its constituent colors because of refraction. So the next time you see a rainbow or a mirage or even yourself in a mirror, you know that there's no more to it than the play of light waves. And that's it. So I hope you guys learned something from the reflection and refraction of light tutorials. And I will see you guys next time. All right. Have a good one.